So hello friends, myself Piyush Lokhande and today I am solving section C of first internal test paper. So our first question is solve x square minus x minus 1 using Newton-Raphson method up to 4 decimal places. So our function is x square minus x minus 1. So first we will find the root for this function by putting different values for x. For example 0, 1, 2, etc. On putting x equals to 0 in this function, we get f of 0 equals to minus 1. Then we will put x equals to 1, we get f of 1 equals to minus 1. Then we will put x equals to 2 in this function, we get f of 2 equals to positive 1. Then we will stop when we get one negative value and one positive value for this function. Now we will consider our root lies between 1 and 2. Now we will find differentiation for this function which is 2x minus 1. So our initial guess is x0 equals to 1. Then by Newton-Raphson formula xn plus 1 equals to xn minus f of xn divided by f dash xn. On putting n equals to 0 for first iteration in this formula we get x1 equals to x0 minus f of x0 divided by f dash x0. So on putting the values, we get x1 equals to 1 minus under bracket minus 1 divided by 1. So on solving, we get x1 equals to 2. Now when we put n equals to 2, n equals to 1 in this formula, we get x2 equals to x1 minus f of x1 divided by f dash x1. Now we will put values of x1, f of x1 and f dash x1. So we get 2 minus 1 by 3. On solving, we get x2 equals to 1.6667. Then we will put n equals to 2. Then in that formula, we get x3 equals to x2 minus f of x2 divided by f dash x2. Then on solving, we get 1.6667 minus 0.04761. And on subtracting this both the terms, we get 1.6191, which is the value of x3. Then when we put n equals to 3 in that formula, we get x4 equals to x3 minus f of x3 divided by f dash x3. Then we will get x4 equals to 1.6181. Now we will put n equals to 4 in that formula and we get x5 equals to x4 minus f of x4 divided by f dash x4. On solving, we get x5 equals to 1.6181, which is the root for that function. Now our next question is write an algorithm flowchart or program for finding square root of 7 using using fixed point iteration method. So we have written an algorithm which is which first its first step is start. Then in second step we will define a function f of x. Then in third step we will define a g of x function which is obtained from f of x equals to 0 such that x equals to g of x and g dash x is less than 1. Then we will choose initial guess x0 error e and maximum iteration n. Then in fifth step we will initialize iteration counter as step equals to step plus 1. Then in sixth step we will calculate x1 equals to g of x0. Then in seventh step we will increment iteration counter step equals to step plus 1. Then in eighth step we will check is step greater than n. If it is true, then we will print not convergent and we will move to step number 12. And if it is false, then we will move to step number 10. Then in step number 9, we will set x0 equals to x1 for the next iteration. Then we will check a condition in next step, which is f of x greater than e. Here e is the error. If it is true, then we will move to step number 6 again. And if it is false, then we will move to step number 11. Now in step number 11, uh, we have to display x1 as a root, and then in last step, step number 12, stop. Now our next question is give the stepwise output of Gauss elimination algorithm for given matrix. We have given a matrix and we have to find using Gauss elimination method. So in Gauss elimination method, we have to convert matrix into upper triangular matrix by the help of diagonal elements. For example, we have to convert matrix in this form. This element should be 0. So we will perform various row operations in this matrix to get answer. So first we will make this element this and R3 of this element and R4 this element 0 from this first diagonal element. So we will perform various row operation. For example, R2 tends to R2 minus under bracket minus 6 by 10 R1, and R3 tends to R3 minus 3 by 10 R1, and R4 tends to R4 minus 5 by 10 R1. On applying this row transformation in this matrix, we get our new matrix, which is this. And now we have to create this element as 0 by the help of this diagonal element. So we will perform row operation on R3 and R4. So this is the row operation for R3 and R4. R3 tends to R3 minus 3.1 divided by 3.8 into R2, and R4 tends to R4 minus under bracket minus 5.5 divided by 3.8 into R2. On performing the row operation, we get our new matrix, which is this. We have make these two elements as 0 by the help of this diagonal element. Now we have to make this element as 0 by the help of this diagonal element 2.44. So we will perform row operation on fourth row. So R4 tends to R4 minus under bracket minus 2.34 divided by 2.44 into R3. So we will get our new matrix, which is this, and this is the output we needed. Now we have to find value of w, x, y, z from this matrix. So we will create different equations. For example, first equation is 10w minus 7x plus 3y plus 5z equals to 6. The second equation is 3.8x plus 0.8y plus minus z equals to 8.6. And the third equation we get is 2.44y plus 10.31z equals to minus 6.81. And our last one is 9.93z equals to 9.90. So first we will solve for z. So value for z equals to 9.90 by 9.93, which is 0.9969. Then we will put these values of z in this equation to find the value of y. On putting value of z here, we get y equals to minus 6.9946, and for to find x value, we put y value and z value in this equation, and we get value of x equals to 3.9980. Now we have to find the value of w. So we will put x, y, z value from this and this equations. So we get w equals to 4.9985. So this is the required solution for this matrix. You can check it. For any doubt, please